Hello. In this video, we're going to be talking about the typesetting program LaTeX that we're going to be using in our lab assignments for the semester and throughout the entire physics sequence. So I'm going to start basically assuming you have no idea what LaTeX is. We'll show how you can access the editor online and some of the basic commands for how to structure your writing in a lab report. So I'm going to be sharing screens throughout this video. Just the first thing is just to make sure we understand what the word is. So LaTeX is written like this. It's pronounced either LaTeX or LaTeX. I prefer LaTeX, so that's what I'll be saying. The reason why is this X is not the letter X. It's the Greek letter chi, and it's because this is a typesetting program specifically used in technical writing. So a lot of the scientific fields like chemistry, biology, physics, engineering, computer science, a lot of basically all of the professional mathematics, all the professional publications are not typed in an editor like Microsoft Word. They're typed in an editor like LaTeX, which allows us to render equations and figures and diagrams better. So, for example, when you get your textbook, which I'm sure you guys all have, either the physical version or the e-text, your textbooks were written in LaTeX because anything that has an equation in it is most likely be in LaTeX. And so there's a bit of a learning curve for how to use this, but it will be useful and less of a pain later on once you get used to the hang of it. So it's a really powerful tool and it makes your stuff look very professional. So in the past, you had to compile your LaTeX things in a terminal, and we don't need to do that anymore because of the internet. So what I'm going to do is I'm going to show you, I will share my internet website. And then what we need to do is open a new tab right here. And we're going to go to a website called www.overleaf.com. And when you go there, it'll have you log in. So you can log in with your Google account is probably what I would do. So I will just log in with Google. Okay. So anything that you've written and worked on will appear here, and eventually we'll talk about how you can organize these. You can make tags. So I have different tags for different classes that I teach, and you guys can do this as well for your classes. But if you're just starting, the main thing we want to hit right now is new project. And then when we open that, we want to hit blank project over here. So we'll just say test. You can call it whatever you want. If anything pops up, just get rid of it. Okay. And in this video, I want you guys to make your own project, follow me along. So if we were in a classroom, I would have everybody on their own computer and we'd be making this. So make your own along with me. Pause the video as many times as you need to make sure you're on the same page as me, because this sample template that we're making, you guys will probably save it in your Overleaf account and then you can use it back when you write your lab reports. So it's good to have a baseline thing to work with and to copy over if you need to. So the main idea here is it's going to come up with a bunch of stuff and we want to look at what each of these lines means. So the first thing up here, the document class article, this is telling us what the document's going to look like. So it's like you would use that to say, how many columns is it? What's the format? What's the margin size? Like just the visual document. It's like opening the standard template in Microsoft Word. So we're not going to change that for now, but eventually we will edit it to change the font size and other things. The next thing is just to allow you to put images in your file, which we will need for lab reports, and we put figures and tables. And then the title, you can imagine is the title. So whatever you have written inside these brackets right here will come up as your title. So I can say, let's just say new title. And when I click away, nothing happens here. So what we have to do in order to go from what we call the source code over here to the visual PDF file that you're going to be submitting is we want to compile it. So there's this green button here that says recompile. So I'll click that. And then now the words new title at the top match what I put over here. So you guys can change, I want you to change the title on your sample assignment just to make sure you can change it and recompile it. A lot of times going over here and manually clicking the green button is annoying. So you can also just hit Control S or Command S, whatever the save feature is on your operating system. So we'll just say, we're going to try again. And I'm going to do Command S. And when I do that, you can see that the recompile button is moving, and you can see now it has try again as my title. Obviously, we can change our name and our date, and those are like the default things that come up. So it's good to just have a title, a name, and a date on all your assignments. So all this stuff at the top is called the preamble. And the preamble is basically just the text that comes before your actual report. So the report is this part where it says begin document, blah, 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 and then end document. The things between begin and end are the body of your report. So the preamble comes before that and basically gives you the settings of your paper, the visual settings. And so we will edit the preamble together during this video. And then I have the editing things that we come up with in your lab report guidelines. So if you forget them or you lose them, you can refer back to the lab report guidelines and we'll tell you what you need in the preamble to make your report fit the formatting. Okay, let's see, what do we want to do next? So when we're writing reports in this class, scientific papers and publications are usually not one-person enterprises. Usually there's a group of people working together. And often there might even be a larger group of people working together, but then a smaller group of people writing together. So to model that, we're going to be doing a lot of our assignments. We'll do some assignments individually, but some assignments in pairs or triplets of people writing together and submitting the same writing. So if you want to do that, then you go to the author over here and you'd want to put your name and your lab partner's name. So say I'm writing my lab report with the person sitting next to me. So I would say Robin Rehagen and just making up a name, Jessica Wu. Okay, and I would compile that, and then it would have both of our names here. So what if me and Jessica were writing our report together, but we also had two other people at our table that were writing their report together? And when you turn in your report, I do want to know who you were working with. So we're going to put a footnote that has the other people's names. And so the way that you put the footnote when you're in this author format is inside the curly bracket. So you can see that this is cordoned off by curly brackets. So inside, after the final character over here, you want to type \thanks and then two more open and close curly brackets like this. Again, feel free to pause the video if you need to, because I want you to write it in yourself and make sure that you can follow along with me. I'm going to just keep talking, but you can pause and then make sure you catch up. Okay, so inside the thanks, we're going to put the names of our other lab partners. I'll just say Albert Einstein and who's another famous person, famous scientist. Okay, we'll do Marie Curie. Okay. And then I'm going to hit Apple S because I have a Mac. We can do Control S to save it. That recompiles it. You'll still see the first two names on the top, me and Jessica are writing the report, but now you can see an asterisk. And if we scroll down over here, here is Albert Einstein and Marie Curie. So those were our lab partners. And so when you turn in the reports, whoever's getting the grade on the assignment, their names should go on top, but then any other people you worked with, their names should go on the bottom using this thanks command. Okay. And that'll change because some assignments are in groups, some assignments are individual. All right, so that's the next thing. Okay, so that sets it up for us. So the next thing we want to do is go into the document itself. So we have our name. Let's give it, we have our name, we have our title. Now we're in the document. So the first thing we see is We see two, the spaces here don't matter, by the way. Um, all of these backslashes are telling you that it's a command. So the spaces between the commands don't matter. I am going to say, I'm going to show you a special type of character called the comment. You can actually see it over here. So the comment symbol in LaTeX is a percent sign. And when you put a percent, it means the program is going to ignore all the text after it. So you can read it in the code, but it's not going to appear in the document. So if I want to get rid of my title over here, I can put a comment sign, a percent, in front of the make title. It turns it green. I hit save, and then my title just went away. So don't do that. You're going to want a title on your report. So I'll get rid of the comment, but you can just see what happens. So if I put it back, that, you can also see I could get rid of the section, this introduction section over here that's numbered. I could comment that out. Usually what comments do is they allow you to write notes to yourself or your lab partner that you're working with. So if you're like, hey, let's fill out this paragraph a little more, you can put that in a comment and it won't show up in your text, but you can remind your lab partner that you still need to work on that paragraph. So I'll use them occasionally. And also if you're like, you're not sure you want to keep a command in, but you don't want to delete it because then you'll forget what it is, you can just comment it out and then you can bring it back later if you need to. Okay. So we have our title, we have our section. I'm going to put it back in, take my comment away. And you can see that it has a number 1 next to it. So in LaTeX, they will automatically number things for you, which is really nice. So in our scientific papers, we have 4 sections that we're going to be using for our lab report. And we'll talk about these in more detail when we talk about how to write the reports. But for now, I'll just give you the titles. And so you can make them on your own document as kind of just a practice for the lab reports. So you're going to write section. You'll notice once you start typing it, a drop-down will come that has it listed there, and you can just hit tab and that will fill in the whole thing. Second section is called methods. The third section is called data analysis. The fourth section is called discussion. And then now I'm going to compile it by hitting save. And when I compile it, it has all 4 sections titled and numbered. You can also have subsections that you'll see. So if you want, like say you want your method section broken down into 2 sections, you can type subsection, first experiment. These are terrible titles. Don't actually use them in a report. I'm just using them here. Second experiment. And if I were to do that under there, you would get the subsections 2.1 and 2.2. So those are all generically part of section 2. Okay, so you can, depending on your lab, it's going to be very different. You might need different sections, but you'll always need sections 1, 2, 3, and 4. That's sort of the requirement. Okay, so those are our sections. They're like the headings in our report. And so the next thing we want to do is put the actual text. So go into any section. We can just start with the introduction. Press return a couple times to give you some room. So you would just start typing. So this is a new paragraph. Okay, so I'm just typing. And when I do that, you can see that automatically the sections are bolded and large. The writing in the paragraph is small. All of that, font choice and font size came from our document class article, came from this. So it's all set by this thing over here. So you don't have to do any formatting. You just use the formatting inherent in LaTeX, and then you can get a professional looking report. So if we want to keep doing this, we want to see what happens when we have a paragraph. I'm going to just copy my fake sentences over and over again so it looks like it's longer, looks like a paragraph. And then I say, how do I get a new paragraph? So all you have to do is double space like that. And I'm going to copy this, paste that, double space again, just to have a couple sample paragraphs. And then when I control save and I recompile, I get something that looks like that. And you'll notice, again, so pause the video, do that for yourself so you can see what it looks like. You should notice that there are indents. There's no indent in the front here right after the introduction, but there are indents in the subsequent paragraphs. And that's just part of the style of the scientific paper, the document class article. It's just ingrained in the style that you don't indent the first paragraph. So you don't have to try to worry about that. Okay, so that's it. That's the paragraphs. I want to just note, so right now, this button on the right, this little arrow here, it can be minimized or not. Later on, when you get, we have a short report right now, it's like 1 page long, but when you get to like 10 pages, you might not want to scroll through your whole report. You have a nice file outline here, and if you click somewhere here, it'll bring you to the part of the code that's associated with that part of your file outline. So if that's 6 pages away, you can just click it here. For the moment, we don't need this, so I'm going to just minimize it, but just know that it exists right there. Okay, so we have sentences, we have paragraphs. So let's look at the indents a little more closely. So we said that the indent here happened because of the formatting of the article. But when I wrote here, I didn't actually include an indent. So what would happen if I include an indent? I want you guys to try this. I'm going to put a tab there, and I'm going to recompile. And we want to look at this final paragraph to see if anything changes. And you can see that nothing changes. So the indents are superfluous. They don't mean anything. So there's some computer programming languages where indents do matter. They do not matter in LaTeX. So I would just not put them in. Same with the spaces. Like if I put a bunch of spaces there, or if I put like a bunch of spaces here for no reason, and then I recompiled, nothing changes here. LaTeX is just going to ignore the extra spaces and extra indents and make it look nice. Okay, so indents and spaces don't matter. Okay, so then as we go through the report and we get all these different sections, you will be in the course of your document referring back to different sections. And so it's good to be able to label the section so you don't have to remember, oh, what's that section 2.2 or section 2.1 or whatever. So there's a nice built-in way to do this. So we're going to go back to our introduction. After the word section, you can put the word /label and then the curly brackets. And inside those brackets, we're going to create the label for the section. Now, what we don't want to do is call it section 1, because then we have to remember the number 1. And the whole point is we don't want to remember. So we're going to call it, a standard way of labeling is to use SEC for section, colon, and then intro for the introduction. So that way you don't have to remember the number, but you look at that label and you're like, oh yeah, that's the introduction section. So I can do the same thing over here. Methods, label, sec, methods. You can write out the whole name of it if you want, or you can just abbreviate it to 1 or 2 letters. Doesn't matter. This is your choice. I'll call it experiment 1. I'll use the same label here. Call this experiment 2. So you can just go through and label everything. And they should all be labeled. How that, when I compile it, nothing should change because I didn't actually write anything. I was just labeling my sections. And you can think of this, if you've had any experience with computer programming, you can think of this as assigning a variable. So the number of the section, like 2.1 over here, is the output of the variable, and the variable name is sec:(experiment 1. And so you can move these around. Like you could decide that actually you really wanted these subsections in your data analysis and not in your methods. And so when you do that, when I move them around, they get put in data analysis. Now the number of the is changing. It's 3.1 instead of 2.1, but the variable is the same. So I can still refer to the variable and it will track the fact that I changed that stuff and put it in the other section. So it's just cleaner programming to use the label than to manually type out the section number. And we'll find that that's true for all things in LaTeX: section numbers, figure numbers, equation numbers, table numbers. All of those things should be referred to by variables rather than by the actual number written out. And so we'll try to practice that. Let's actually do that right now. We can write a sentence to practice it. I'm going to just start in my methods section. So I've gone in the methods. It's like, here is a sentence referencing section, and let's reference the section, the second experiment. So the variable I'm trying to get is 3.2. So I could just write referencing section 3.2, period. I could write that, but then later on, when my lab partner is coming in and moving sections around, that 3.2 might no longer be accurate. And before we were using LaTeX, but for lab reports, students had this problem all the time. All their figure numbers and their section numbers kept moving around, and it was confusing. It was hard to know what was going on. So instead of writing out the number, what we're going to do is write out a reference variable. So we're going to reference the variable, and you can see all of our labels come up. And I wanted to reference 3.2. I know that's experiment 2. So I'm going to do that. And now when we look at our, let me just zoom in a little so you can see this. When we look at our methods, we can say, here's a sentence referencing section 3.2. So it puts the number in when I put the variable in. And so it might seem clunky to do this at first, but it actually will save you time and it's clearer in the long run. So get used to using the references. Let's just, I want to just show you how this reference will track the variable. So I'm going to take these two 3.1 and 3.2 that we just put there, and I'm going to go put them back in the method section. I'll be like, oh, I made a mistake. I want to put them back. Get them out of here. When I recompile it, the numbers will come back here and this number should change. Let's see if that happens. Yep. So the 2.2s came up here and my variable changed from 3.2 back to 2.2. Okay. And we'll do this again when we get to figures and tables as well. Okay. So I'm going to zoom back out on this document, and I'm going to zoom out all the way so we can just look at it. And the first thing you should notice is when you look at it, it has really fat, wide margins. And that's a lot of wasted paper, and we don't want to waste paper. And I don't want to carry a lot of heavy reports that are unnecessarily large. So we want to get the margins more reasonable. Typically, people use 1-inch margins, right? So let's go back and make these 1-inch. Now we said that the whole layout of the paper was given by this line, document class article. So whatever this line is it naturally just has really large margins. And what I want us to do is imagine a piece of paper. Just hold up a folder here. This piece of paper is normally like printer paper size. What are the dimensions? Should be 8.5 by 11. So if we want 1-inch margins, we want to cut off an inch on both sides. So instead of 8.5, this becomes 6.5. We cut off 2 inches. Instead of 11 inches, the vertical height becomes 9 inches. So we want our text to fit in a 6.5 by 9 rectangle. So what we're going to do is we're going to insert a new line under document class article to clarify the margin size. I'm going to write use package, and we want the use package one that has first the square brackets and then the curly brackets. And in the square brackets, you're going to say letter paper. and then comma total equals, and then we're going to introduce new curly brackets. And this is where we're going to do 6.5 inches, comma 9 inches. And then in the final curly brackets, we're going to write geometry. And I'm going to compile this to see if that worked. And we can see now the text is more spread out over here. And so you only have 1-inch margins instead of the really big margins. Now, try this yourself. Make sure that you can see what's going on. What's this stupid thing? Can't see the word geometry. There we go. Just make sure you have it typed in properly. Sometimes if you like put a space in the wrong spot, or put the bracket in the wrong spot, it just won't work. Or if you spell letter paper wrong. So just check that it's word for word what I did if you're having trouble, and this should work. You can always come in office hours if you can't get this line to work too. Okay. And this is also in the lab report guidelines. So let me actually just share that with you right now so you can see. Let's go to, so if we go to our physics website, this is just the front page. It's got my office hours. It's got these things called quick links. So under lab, there's a bunch of stuff over here. So you can see there's some LaTeX things over here. This is for lab reports. But generally, most of the information you'll need is this first link where it says laboratory information. So if you click here, we've got a lot of things. We got how do I write a lab report? How do I calculate error? How do I make plots? What is my software? All these things are here. So in the lab report, if we go to the first one, this lab report guidelines file has a lot of stuff in it. So I'm going to open that file for you so you can see what it is. Look at the beginning. There's a lot of stuff. It's about the different sections, and that's like the writing content of what goes in the section. And then there's a bunch of stuff about formatting right here, section 5, which is mainly the things we'll be talking about today. So how do you format the document in LaTeX? That's what we're doing now. How do you format the figures and tables and equations? And so if you forget any of these things, you can go back to this lab report guidelines. So let's go over to section 5, which I believe is over here. Section 5, formatting the document. So we talked about the preamble is the thing that comes before the main document. These are these 4 lines. So the document class came up and the use package came up automatically. This one here, the letter paper one, we are adding. And you do need to add this manually every time you open a report. So if we go back to the report, I had to add this manually right here. It doesn't matter what order they're in, by the way, just anywhere is fine. They do need to be before the words begin document, or else it's not the preamble. Okay. So as we go through, we'll add there's one last command that you put in the preamble, but then after that, or maybe 2 last commands. And after that, you can always go back to the lab report guidelines, or you can copy and paste from the sample thing that we're doing right now, just so you have the right preamble. Okay, so we've got our document with better margins. Now, I will let you know that the default font size that LaTeX gives you is 10 point, which is very small. And I no longer have 20-year-old eyes, so I do not like to read small fonts. So the absolute minimum font I want you guys to use is 12 point. So what we have to do in this article over here is we have to tell it to get out of the default and go to 12 point. So what we do is we put it in between the words document, class, and article. We put square brackets and 12 PT inside the square brackets. And then I'm going to say save, and I'm going to watch the font size increase on my document. Okay. And trust me, I will know instantly if you did not change your font size, because I won't be able to read it and they'll send it back and make you print it again. So make sure you use the proper font size. 1-inch margins, 12-point font, just standard on paper writing things. Okay, so up until now, like getting your margins in your font, making paragraphs and headings, all of this stuff can be done with like Google Docs or Microsoft Word. So that's not the reason we use LaTeX. That's just teaching you how to use it. The reason we use LaTeX is for the equations and the figures. And those things are a lot harder to do with Word or Google Docs than they are with LaTeX. So we're going to start with equations. Um, and I just want you to note, and you can take a moment to do this right now if you have your physics textbook, to just look through your textbook and see how the equations are organized, like where they are on the page. There's really like when you're writing a sentence in a scientific paper, the equation is being treated as a word. So I'm just trying to think of a random sentence. You can be like, Newton's second law is F equals ma, period. Newton's second law is equation, F equals ma, end of sentence, period. So the equation is inside the sentence. You would never just have an equation floating around between two sentences that have periods. Like it's actually part of the sentence. And so there's three ways to format the equation visually, but 100% of the time it's going to be part of the sentence. So I'm going to I'll show you what this looks like. Let's go back to our method section over here. I'll just copy and paste this paragraph just so it looks more paragraphy, and then we can start a new paragraph below. Double space, and we're going to start an equation. So I'll write the equation that I said. Newton's second law is F equals ma, period. Okay, and I'm going to compile that. So, and ignore the funny location of the footnote here. It's annoying. Okay, so you can see that that looks okay. I'm going to just zoom in so we can see it more clearly. Newton's second law is F equals ma. This is the general way you would write an equation into a sentence, but the formatting here looks kind of bad. It doesn't look nice like you would have in your textbook. And the reason is because we haven't gone into equation mode where it makes the font look different. So to go into equation mode, we want to put a $ before and after the equation. F equals ma like that. And when I recompile, now a couple things happen. First thing is the equation is more spaced out visually, so it's easier to read. The second thing is the variables have been italicized. So that's just a general rule for equation formatting. If you see a letter that's italicized, that means it's a variable. And here, F is force, M is mass, A is acceleration. They're all variables. So that's how we would insert into the sentence. And just remember to always put proper grammar. So there should be a period at the end of that sentence. Now, I could write the sentence a different way. So say I have a equation that I want, there's kind of like two reasons you might want to do this. I want to have the equation centered on the page. I'm going to double space and we're going to do it again. So we'll just copy this whole thing. I'm double spacing, so it's a new paragraph. Newton's second law equals F equals ma. I'm going to put $2, and that's going to center the equation on the page. So I'm going to zoom out a little bit so you can see it. Okay. Newton's second law is F equals ma. It's still in the sentence. Awkwardly, though, the period is sitting over here because I put the period outside the $, and the $signs are what's centered. So I'd actually, if you want to do this, you would have to put the period inside the $signs so that the period appeared at the end of the sentence in the centered thing. And that might look weird to you at the beginning. That's just like the style. That's the scientific style. Some textbooks choose to ignore the period, to like just not even put the period at the end of the sentence at all. But that's not what you would do in a professional publication. You would put the period at the end of the sentence. So some textbooks do it, some textbooks don't. In our class, we're gonna do kind of how the professionals write in like publications. So we're gonna put the period inside the equation, and that would be on the same line if it happens to be, if the equation happens to be in the middle of the sentence like that. If it's not a period, but like a longer sentence, you could also put a comma there. You want to put some sort of grammatical thing. Newton's second law is F equals ma, comma, where F represents force, m represents mass, and a represents acceleration. Okay, so this sentence, Newton's second law is F equals ma, comma, and then it continues. And you can see a couple things. The first thing is that the equation is still a word inside the sentence, but the sentence is long. And even though the equation is centered, it's still inside a single sentence. The sentence hasn't ended. And because of that, grammatically, we need a comma here. The other thing you can see is that the F, the M, and the A, when I continued to use them afterwards, I still had to put them in equation mode to make sure they had the correct italicization and font so that you can separate a variable from just a random letter that's floating around. Grammatically, you don't always need punctuation here. So I could write a sentence. It depends on the grammar of the sentence, but let me think of one that doesn't need punctuation. You can say Newton's maybe how about like we measured a force of, you can say F equals 25. Um, I'm going to do something. Oh, yeah. Okay. We measured a force of F equals 25 newtons in our experiment. So you can see how there doesn't need to be a comma there. So grammatically, we don't need the comma, so I don't put the comma. So when you need a period or a comma, you would want to put it, make sure it's centered with the equation. If you don't need it, that's fine. You can just continue the sentence. One thing I'll mention here is that when you do put units in, there is a difference between a variable and a unit in equation mode. Variables are italicized, and units should not be italicized to differentiate them from variables. But if I put a letter N here in my parentheses, LaTeX will assume it's a variable. So you have to manually get rid of the italics. So we're going to use the command \math rm, math remove, and we're going to put these brackets around the N. So when I do that, the N is no longer italicized. I also don't like the fact that there's no space between the 25 and the N. Remember, if I put extra spaces here, LaTeX is going to ignore it, right? Nothing happens. So to get a space, you have to do something kind of tricky. So there's these, I think I put this in the lab report guidelines somewhere, but there's these commands for spaces. Usually there's a couple depending on how wide you want the space. Kind of the standard size space is \::. So you can see that that is putting a little space there. I'm going to compile this and you can look at the output over here. And you can see that the space is a little larger. Okay. So those are kind of the two main types of equations. Either you have the equation in the sentence. Honestly, for a sentence like this, I would probably not center it. So I would actually use the single $sign mode here rather than the double $sign mode. And I'll recompile it so you can see. I would just put it like this. We measured a force of F equals 25 newtons in our experiment. And the reason is because there's only two reasons to center an equation. One, the main reason is when the equation is really big. F equals 25 newtons is not really big. If I wanted to make a big equation, let's just make a really crazy equation. So let's use the equation. I'll do the centering mode, put my period there because I know that that's the end of my sentence. Something with a fraction is something that's just visually big. So we can use a fraction. The command is frac, fraction followed by two of these things. And I'll call it 1 over x. So let's use the equation 1 over x. And let's just put like y equals 1 over x. So the first thing you notice is that the 1 over x takes up two vertical lines. So if I tried to put this in the normal equation mode, like if I got rid of the double dollar signs and just put $1 then it's going to make it really, really tiny to make it fit. And that is just, it's hard to read and it's ugly looking. So what I would just suggest is that when you have an equation that has a fraction, like a vertical fraction, always use a double dollar sign. Sometimes if you have things like a square root, which is backslash SQRT, I'm going to just make it some, let's get a variable. We'll do z, square root z over x. That square root is sometimes taller than normal text as well. If you have a square root over a fraction, or maybe you want a parentheses around the whole thing, you can imagine making the equation really big and wide, and that's the reason you would want it centered. The other equation time is sometimes it's just really important. You want to center it to make sure people see it. But I would say it being big is the main idea. There's one additional caveat for equation mode is you'll be writing a lot of equations in your reports, but some of them you will need to refer back to. And like, say this y equals square root z over x, say this is like your fundamental equation for your paper, and all in your data analysis section, you constantly refer to y equals square root z over x. You don't want to write that equation 50 times. You want to give it a number, call it equation 1, and then just refer back to equation 1. So we can't give these numbers in the type of format that has the dollar signs. The dollar signs is like you use it to write the equation quickly. If you want a number to refer back to it, we have to write a special mode. So I'm going to copy and paste this sentence over here, but we're going to change the equation mode. First thing I'm going to do is I'm going to put it on its own line. And that is okay because, look, let me just compile it so you can see. It looks identical, even though I put it on its own line. And the reason is because you need a double space to tell it to new paragraph. A single space won't confuse LaTeX at all. It just ignores the single space. We're going to get rid of the dollar signs because we don't need them in this next mode. But we're going to add the words begin equation. Whoa. Sorry, still need that. Okay, try to get begin equation. Now, in the begin equation, when I hit tab, it automatically gave me an end equation. And I want to put this equation in between the begin and end equation with my period, since it's the end of the sentence. Now, when I compile that, it'll look exactly the same, but now there's a number off to the side. And we can use the label to label the equation. So I believe you just put it over here, label. And I want to label this instead of sections. Remember, we labeled section experiment 1 down here. You can see it. My label, I'm going to start with EQ to indicate an equation. We don't want to call it equation 1 because we might add another label in front of it. The number 1 might change, but we want to give it some meaning. So say this equation has to do with the meaning of the universe. So I'll call it equation universe. I made it up, so it has no meaning. But like this equation over here, like Newton's law, you might call it equation Newton, just so you remember which one it is. So just make sure that when you're doing the labels, you don't put numbers in them. That's the key. So then what I could do is I can continue on writing, and I could say, throughout our experiment, we used the equation we'll say we used equation 1, but instead of writing equation 1, I don't want to write the 1. I want to write reference, REF, and then you can see here's my references come up, and now my equation universe is there. And then I put period. And when I compile that, you can say throughout our experiment, we used equation 1. And even if I move that equation around, the 1 will still change to follow that equation, whatever number that equation becomes. One small thing here, I'm going to copy and paste this long paragraph in my text, just so you can see what these all look like when you have more text. Okay, so when you're writing, there'll be things here. See, I want us to look at the indentation. So whenever there's a double space like this, it'll assume a new paragraph. So when we were doing this complicated equation thing, the thing that we needed to label it, I ended up double spacing this over here, where I'd say throughout the experiment. By double spacing it, it automatically became a new paragraph. So if I didn't want that, I could do two things. One is I could just delete one of the spaces. Now let's watch the indent. It should go away. Okay, so now it's in the same paragraph. But some people like to have these equation things spaced out in their code just to be visually nice. So if you don't want to delete it, what you can do is you can have a double space, but also type no indent like that with a backslash in front. And then when you compile this, oh, I didn't spell indent right. Okay, let's try again. We compile it, then it will go away like that. So that's another workaround that you can do. I would probably put it in your sample document just so you remember the no indent. So those are the 3 equation modes. And let me just show you the lab report guidelines so you can see them in the lab report guidelines. So I'm going to scroll down here. Here we go, formatting equations. Here's your 3 equation modes. This is the one you should use 99% of the time, x equals y, or the single $sign mode. If the equation's really, really big, you can center it. If you need to number the equation and refer back to it, then you use the begin equation, end equation. And you'll notice I don't even have the returns here. I don't even have to put press return after each of those. They can all be on the same line. It just makes it a little easier to look at. Okay, so these are kind of an order of preferences. Don't number every equation by default. That makes your paper look really messy. And if you look at your textbook, you'll see most of the equations they use are not numbered. Most of them are like this. Some of them are like this. And then the least of them are numbered, but those are usually the important ones that they have to refer back to. So I gave you just a little sample right here where you can see all 3 types of equations in use. Our numbered version, something like this, where the V naught's in the middle of the sentence, that's also equation mode, right, for our variables, but it's, it's only a single $sign. And then this would be our double $sign with no reference over here. And I put the source code here so you can see. Okay. I'm going to pause this right now. That's not what I wanted to do. So before we continue past equations, I just want to make sure that we try out kind of a complicated equation and then figure out how we'd know what symbols to use. So the first thing I'll share is just, this is in the lab report guidelines. And it lists really common LaTeX math commands. And the thing is, you just have to learn these and you'll get used to it as you go along. First thing is that everything is spelled out with a backslash. And specifically, we'll be using a lot of Greek letters to represent mathematical concepts in physics. And so all you have to do is know how to spell the letter and know what it looks like, and then you can get the Greek letter. And we'll introduce these one at a time. So this is lowercase sigma. So if you type backslash sigma, you'll get that. If you want an uppercase sigma, which looks different, then you need to uppercase the word sigma. Same with the delta. I give the example. And the entire Greek alphabet is represented like this. Obviously, there are letters, Greek letters you don't know yet, but you'll learn. And then this is how we would write them in LaTeX. The other thing we'll need is operators. So times, dots, and vector symbols. We do a lot of vectors in physics. Normally, if you're just writing like x times y, you would just write x, y with nothing in between. So that's the like algebraic multiplication. But if you have vector multiplication, then you do need these different product symbols, and we'll talk about them as they come up in the class. The other symbols you typically need are superscripts and subscripts, shown here. Note that if you have more than one letter, like say this was x net instead of x sub n, you would have to write the whole net inside the brackets to get the whole word in there. Plus or minus symbol comes a lot when we're doing errors, less than, greater than, equal than, square roots, integrals, fractions. And then these last three are useful because it produces pairs of brackets that resize to fit a larger equation. And I'll show you what that looks like in a second. So again, these are in the lab report guidelines. You can have those out. You can also Google any LaTeX command, and you'll find what you need. So let's go and look at an equation that I want you guys to write. So I want you guys to look at this equation on the bottom, this complicated equation, and I want you to try to write it out on your own. So pause the video and go through and try to figure out what these Greek letters are. And then what I'll do, so try it now, you've tried it. I'm going to go up here and I'll just highlight what I wrote there to get that equation. So if you need any help, you can go look at that highlighted section. And then I want to do one other thing where we change the size of the parentheses. So these parentheses and the sign, I actually had to put in manually. So see the parentheses right here, this right there, and then it's giving me the other parentheses. That didn't come with the sign function. I had to add that in. And just note that if you don't put the sign function in like that, if you forget the backslash, the font of the sign will change and some weird things will happen. It thinks it's variable s times variable I times variable n. So for all of our functions like logarithms and sines and stuff, we do need to have the backslash to get the font and the formatting correct. But this is like a small, like one line argument, omega t plus phi average. What if I wanted it to be phi average divided by 2? So what I'm going to do is I'll put a fraction symbol here. I'll put the phi average there. Then I'll put the 2 there. So now it's phi divided by 2, but you can see that this parentheses sign is not actually covering the whole thing. So we need to increase the size of the parentheses. So if you put a backslash left parenthesis, so this whole thing is one command, backslash left parenthesis. And then here I'm going to do backslash right parenthesis. And when you save, then these things will automatically resize to the right one. I don't know why it's giving me an error here. It doesn't like one of my there, let's try that. Okay, well, I'll fix it anyway. If you see a red thing like this, don't be lazy like me, but actually go figure out what's extra. I've forgotten right. Let's see. I don't want to waste your guys' time trying to figure this out. Oh, I think this one is the extra one. There we go. Okay, now the red thing's gone. So yeah, if you have like a red line commented or like thing like that, that means there's an error. You can also, let me just add it back in so you can see the error again. Add the extra bracket. So the red dot means there's an error. It's saying there's an unclosed dollar sign found at this closed group. So what that's just saying is it's confused. One of the, either the dollar sign's wrong or the bracket's wrong. And it doesn't know which one because it's just the computer. So you have to go and look at your input and figure out which one was wrong. And it was that I had an extra bracket. Um, if you look at this, usually there's a way. Sometimes there's this section where you can see the error message if it's a really large error. I don't see it right now, but you can always see what the error is if you hover over this dark red dot. Okay. So you want to fix those dots because LaTeX will try to fix it. So if we look at this recompile thing, there's a line at the bottom that says try to compile despite errors. So it's trying to compile it and it's trying to guess what you wanted it to do, but sometimes it just guesses wrong. So it was guessing right for me and it was still showing the equation correctly, but a 50-50 chance that it guessed wrong and it would show my equation incorrectly. So if you don't check your output really carefully and you don't fix the red dot, then you can end up with something really weird happening like 2 paragraphs later and you're like, what's going on? It's because you had a, syntax error. So we want to get rid of that extra. Okay, so anyway, I just wanted to highlight that these large parentheses are what you want whenever you have like a stacked fraction like this. You don't want to make it look like the small parentheses. It just looks ugly. Okay. So eventually, the more you practice with the LaTeX math symbols, you'll get used to it. So let's move on to figures because another really big important thing in scientific writing is showing plots and graphs. So luckily, LaTeX sets a lot of this up for you. So we're going to just go into one of our other sections. I'll just start over here and I'll say begin. So I'll start with begin, figure. And here I want you to type tab. Don't write the word begin figure. Either click on this or type tab, because it will populate the entire figure category for you. And that makes this easier. So we have the centering, the caption, the label, and the end figure is already there. So this is going to be really easy. We just need to follow the steps and put the picture in, and then we're done. So the caption here is, let's go line by line. So this means you're starting the figure. This means the figure is centered on the page. Don't change that. We want to keep it like that. This is where you put the picture, and the picture goes between these empty brackets. And right now we have no pictures, so nothing is popping up. So take a moment, find a picture on your computer, and then I will show you how to put it into this file. So I'll pause the recording for a second. I'll get my picture ready. I can figure out how to pause the recording. So I found a picture and I'm going to show you guys how to include it. So this is where we need to open up that side panel. So find the little arrow that can close or open this and open it up. And we want to go to the upload button. So we're going to upload and we're going to either drag the picture here or select it. So I'll just drag it in. A nice sine wave plot. And we can see that there's sinewave.png shows up on the side over here. Okay, so then when I go into my include graphics over here, if I click here, suddenly sinewave.png comes in. So it will recognize graphics files and it will let you click on them. The caption is the description of the picture. We'll talk more about the details of what goes in this. For now, just write a random sentence. Just say, this plot shows a sine wave, period. And then here, we're going to give it a label. So they already have fig for figure, so we'll put fig wave, and that'll be the label. And so now I'm going to compile. I'm going to hit Control S. And we don't see it yet because there wasn't enough room on this page. So we're going to have to scroll down, zoom out. Let's try to find where this picture is. Oh, it went to the top of the page. So LaTeX is going to try to put the picture wherever it sees fit. Okay, so it's sitting at the top of the page. And let's make some quick changes. So this is I will get rid of that. You don't need that right now. You can see my caption here. This plot shows the sine wave is underneath the figure. We always want it to stay there, centered and underneath. So just don't change that. And you can put your words, what you want in the caption there. Usually captions are longer than this. They're like a paragraph, but we're not focusing on the writing right now. Now the picture is kind of small. You can see it's a little bit hard to read the axis labels even when I zoom in. Typically, we want our pictures to be large enough so that the smallest typing on the picture is the same as 12-point font. I would just generally go to the full width of the page. So if this is your page, we want the picture to take up all the room it can. So right here it says width equals 0.5 line width. That's the default. I'm going to get rid of the 0.5. So the width equals the line width, which is our 6.5 inches. And when we do that, let's figure out where that picture went. When we do that, we see that the picture is much bigger like that. And they moved it off the page because they couldn't fit it on the page, which is fine. Okay. Um, the last thing is in your lab report, you're going to have a lot of figures, maybe like 5 figures or more. And so trying to get them in the exact right spot is probably one of the more tricky things in LaTeX. So what I tell students to do is just take all your little figure code, all the code that's going to give your figures, just stick it at the end of your report. Like, so I'm going to cut this and paste it right before end document. Just put it at the bottom. And I'll put all my figures at the bottom right there. You want to keep them in order because that'll keep the numbering of the figures in order. But the placement doesn't really matter yet. Once you have the whole report written, say all 8 to 10 pages of the report, then you put the figures in as the last step and try to get them to sit where they're supposed to sit. And the supposed to is usually like, if you have the body paragraph over here, and somewhere in the body paragraph it says, oh, figure 1 shows a sine wave, then you want figure 1 to be either on that page or on the next page. You want to be pretty close to that sentence. So let's practice that. So let's say that we're in the discussion and we want to say figure 1 shows a sine wave. But the problem is, remember we said we don't want to put numbers. So what do I need to put instead? I need to write \reference and then fig wave. So that reference tells me the number 1. So I'm going to copy that. And then if we zoom in on the bottom under the discussion, it says figure 1 shows a sine wave. And because our figure is on the next page, we're totally fine. It's close enough to where that sentence was that it works. And generally, you want to introduce the figures in the order that they're in the text. So every time you put a figure in, it should be in this paragraph somewhere. And the first figure you mention, you want to put first, figure 1, second figure is figure 2, second figure is figure 3. And LaTeX will number them for you. You just need to put them in the right spot. If you really want the figure to be in a certain spot, if you go back to this is in the lab report guidelines, I'll show you where it is. You can try to place the figure more specifically. So let's go over here for figures. They give you some instructions on how to create the plots. And then for the placement at the bottom of this page, you can put T for top and B for bottom if you want it to be at the top or the bottom of the page, and that will help. So if we go back to our LaTeX document, like I could put in my figure, I can put T here if I really want it to be on the top of the page. And then if I go over here, zoom out, you can see it's still in the middle of the page because there's no text. But I guarantee you, if I put like 5 more paragraphs of text, the LaTeX would say, oh, okay, I can move this figure to the top of the page. And sometimes it takes a little bit of wiggling it around to figure out where it goes. You can also just like copy and paste this if you want it to be like over here because it's not showing up in the right spot. You can try putting it over there and see if it moves your figure. So that moved my figure. Now it's at the top of this page. Okay, so you just have to trial and error play with it. Okay. So the last thing we got to do is tables. So most of the information you want to display should be in plots, but sometimes like the numbers that you're trying to show don't plot well, or there's just no way to put it in the plot. So then we make a table. And so I'm going to just show you an example of a table from the lab report guidelines. So here's a table right here. We're going to do the one on the bottom. And we're going to just create this table. So this is a temperature table. And there's only 3 data points, so it wouldn't be a very interesting plot. So that's why this person put it in the table. And we can see that there are 2 columns, 1 column here, 1 column here, and that there are 4 rows, 1, 2, 3, 4. So we'll need to create a table with 2 columns and 4 rows. So let's go to LaTeX and see if we can do that. So I'll put the figure or the table over here. So again, it's begin, and it's going to be table. Don't hit tabular, put table, and then hit tab. And so the table thing, you can also put an H or a T. I'll put B for the bottom here. B for bottom, centering, you want to keep that. This part is where you actually put the data in the table in. And then this is the caption under the table. And then this is your table description. And we know this is a temperature table. So I'll call it table tab temp for temperature table. So let's go put the numbers in. My numbers are, I have the temperature in degrees Celsius, negative 4.2, 25, 14.4. This is kind of a complicated table. Maybe I should make it easier. We'll just make up an easier table for this. We can see that we have 2 columns, which is good. So this letter C here represents the column. It's going to show this as default. Get rid of the line in the middle for a sec. So CC means 2 columns. If I wanted a 4-column table, I would just add more C's there. Let's just stay with the 2-column table. Now, what we need to do is we need to put the data in. So actually, let's try to make that the temperature table. It's complicated. It's not the easiest table, but you'll figure it out. So if we look at this table up here, this first line is the heading, just the word variable and measurement. So this is fine. We could make a table like this. Here, if we look at the first line, we see it's actually blank in the first spot. And then it has a lot of information in the second spot. It has the variable, the unit, and the error, which are all good things for the heading. So we're going to have our first section blank, and then this, T degrees C plus or minus 0.1 degrees C. So if we go back to the LaTeX, let's see if I can just share my desktop. That might be easier for this. I can put this off to the side so we can see. I have to keep going between the 2. Okay. So this is going to be the first row of the table. The first thing has to be blank. So here I'm going to put nothing because I'm making the blank thing. Here I'm going to put T, but it's a variable. So I have to put T with the dollar signs. And then I put parentheses, the degrees C. I have to look up what the degrees is because I can't remember off the top of my head. Let's see if it's just degree. I'm going to guess. Doesn't seem to like that. Let's see. Zoom in. Here's my table. Is it making it yet? It's trying to make it at the bottom here. So it doesn't like me making up this degree. It says it's an unrecognized thing. So I'm like, all right, I got to use the internet. So symbol for degree in LaTeX. Okay. So it says you need to use math mode. The caret makes it a superscript, and then circ is for circle. Okay, so let's go back over here. So we're going to go in math mode. We're going to do caret to make it superscript. We need the brackets because we have a lot of things in the superscript. Circ, like that. So now when we look over here, it'll be degree C. The other thing we see here is that underneath this T degree C is the units. And I'm pretty sure what we have to do is just make another row. So this line here says go to a new row. That's what the slash slash means. So our new row is also going to be blank. And then we have this parentheses. The plus or minus symbol is \PM. And then that's in math mode because it's a math symbol, but then we can get out of math mode and we go 0.1. Actually, I can just stay in math mode because I need the circle thing, right? And then the C needs to be out of math mode because or else it'll just be italicized. Okay, so we got the 0.1 degree C underneath it. And then now we're going to put another slash slash to go to the next line over here. And now we can actually start to put the temperature TI negative 4.2. So I'm going to say TI is a variable. So I go into math mode, T sub I. I don't need the brackets around the I because it's only one letter. So LaTeX knows what you're doing. Then we want the and symbol. And the and symbol represents the next column over. So these first columns started blank. And then we had and now this was in the second column. Now this is our first column. So our second column should be negative 4.2. And go to the next one. And I'm going to just copy this over because it looks very similar. TI, TW, TF. This is going to be 25, 14.4. And again, pause this when you need to catch up. Okay. So if we look at our output right now, it looks great. It has all the letters, it has the numbers, the units, and everything, but it doesn't have the lines. So the lines you have to add manually. And if we just look at this document really quick, the choice of line style here is very different than the choice of lines here. And in LaTeX, you literally just draw them in, horizontal lines and vertical lines. So let's do it. The vertical lines have to go in the column section. So I originally deleted this vertical line, but now I want to put it back because I want that line between the two columns. So this vertical line is called a pipe symbol, and on most keyboards, it's on the right-hand side, the upper right-hand side, like under the delete button. At least on my Mac keyboard, that's where it is. So if I put the vertical line between the two C's, we're drawing the line there. Hypothetically, you could put vertical lines on both sides of the C's like that. You could also put a double vertical line if you wanted to make it look like that for some reason. So the visual style of your table is whatever you want. I want to copy this table for now, so I'm going to put just a single vertical line like that. Now we can see that the next thing we want to draw is horizontal lines. There's two horizontal lines under the heading. So there should be no line in between these two because those are just on top of each other. But then at the bottom of the heading, we want a line. And I can never remember if it has to go before or after these. So I'm gonna just try putting H line. Backslash H line means horizontal line, and I'll put two of them. There's supposed to be two lines. See if that was the right spot. Yeah. So you have to put it after the new line. And then I can put an H line between the other two. Like that. And then I've made that table, and it looks basically the same. And again, the visual design's up to you. If you want to make the table look more like this one, that's fine. Or if you want to make it look like this one, that's fine. If you want to design your own, that's also fine. You just want to make sure that the design of all the tables in your report is the same so that it doesn't look like you're changing styles all the time. The last thing we want to do for the tables is actually something in the preamble. So do you see here, it's really subtle, but do you see how the temperature is not too close to the horizontal line above it? But when we look over here, that T is pretty close to that line. There's a special command that stretches out the tables vertically by a multiplicative factor. And it's good, like visually, to have it stretched a little bit. So if we skip all the way up here, and go to the preamble. We have three things in the preamble. There's one more thing I want us to add, and it's backslash renew command. I just tabbed to type it in. In the first brackets, you put backslash array stretch. This is stretching our tables. And then here we do the factor, 1.2. So when I hit save, this table on my right is going to vertically stretched a little bit. And you can see it's a little easier to read. That's like a small thing. You know, you're not going to be marked down if you don't do this, but if you're trying to make your stuff more readable and more visually appealing, adding that last command, it just really helps the tables look nicer. We can see we didn't write a caption. When we get to how to write table captions, we'll talk about what goes inside those captions later on in the class. But that's where you would put it. Okay. So there's a couple final things before we end. The first thing is that there is a spell checker in LaTeX. So let's go into this paragraph and see what would happen if I do that. So the default is that it gets squiggly red dots under it. And that's just telling you that you spelled the word wrong. So just, I mean, you're writing a lab report, so make sure you listen to the spell checker. And sometimes it might not like some of your words, but check, you know, if there's a red line. If you decide you don't like this paragraph but don't want to delete it, just comment it out, and then you can always decide to delete it later. Sometimes you might have to put a LaTeX symbol in your paragraph. So like if I wanted to write the cereal box costs $5. When I try to write $5, it thinks I'm doing math mode. It's confused. It starts making it green. Now it's going to tell me I don't have a dollar sign. Let's see, the error is coming up and it's saying missing dollar sign. And you're like, well, I'm just trying to use the dollar sign symbol. You have to put a backslash in front of it to tell LaTeX, this isn't your dollar sign, this is the other dollar sign. So if I write it like that, let's see if we can find that. Where's this? This is in the introduction, so it's up here. The cereal box costs $5. So now it's actually using the dollar sign. So just know there's a couple special symbols, things like the backslash or the percent. Like if you actually want to put like a percent error, you have to put the backslash in front of the percent to actually get it to not think it's a comment. So just know that you might have to look up some special symbols. Let's see. And then the last two things is how to share and export your file. So with LaTeX, with Overleaf, you can share it with one person for free. So if you're writing in a group of two, you guys can both edit the same document online. You can just share it with each other. If you're writing in a group of three or more, that doesn't work. So you do have to have like one person or two people be the people in charge of putting the things online. And so it might be take a little more coordination between your group members because you can't share with three people unless you buy a subscription, and I don't need you guys to buy a subscription. So just do some communication and coordination. But in general, if you have two people, you can share. So let's figure out where the sharing feature is. Looks like it's share at the top. So you can email somebody over here, and they can be an editor or a viewer. Okay, so you can do it that way. And then when you need to print it, if you go to this button over here where it says download PDF, that will download this thing on the right, the PDF output. And that's what you would print and then submit for your assignment. I do not need to see this part over here, the source code. I just need to see the PDF. Okay, and as always, most stuff, if you Google questions about LaTeX on the internet's pretty helpful, and you should be able to answer most of your questions that way. But as always, you're welcome to come talk to me in office hours, and I hope this was a helpful tutorial. All right, see you later.